Okay, you have this problem in the practice worksheets from class. It is the third one on the non-numbered problems. A person takes his dog out for a walk. The person and the dog walk at a speed of 4 meters per second for the first 5 minutes. They then pick up the pace to a speed of 5.5 meters per second for the next 3 minutes, but get tired and walk at a speed of 3 meters per second for the remainder of the walk. If the average speed for the entire trip is 3.8 meters per second, what was the total distance they walked? Start with our diagram. So we've got the person walking their dog. We know I can't draw already. They're moving. For the second part of the trip, the person and the dog move faster. And then for the third part of the trip, they get tired and slow down. What are we given? Okay, 3 parts of the trip. My subscripts are important here. We know that V1 is 4 meters per second. We know that T1 is 5 minutes. And let's just put that into seconds right now, so 300 seconds. We know that part 2, the average speed is 5.5 meters per second. And the time for part 2 is 3 minutes, which equals 180 seconds. We know that the speed for part 3 is 3 meters per second. And we know that the total average speed is 3.8 meters per second. We want to find the total distance. So we don't know the time for part 3. We also don't know the distance for part 3, and we don't know the total time. So this will end up being a substitution problem, similar to the Siegel problem. It's just a little bit more complicated since we now have 3 parts. So we're going to look at each part individually in addition to the total, and that'll help us solve. Start with part 1. In part 1, we know that speed equals distance over time. We have speed, we have time. We can very easily find the distance by taking the speed times the time. So 4 meters per second times 300 seconds means that my distance covered in part 1 was 1,200 meters. There's my x1. Part 2, we have the same information, so we can find the same things. Speed in part 2 times the time in part 2 will give me the distance in part 2. 5.5 meters per second times 180 seconds, this should be a 2, not a 1, equals my distance in part 2. So part 2 of the walk, they went 990 meters. If we look at part 3, we know that the distance in part 3 will equal the speed in part 3 times the time in part 3. The only thing we have here, though, is the average speed for part 3. And if we look at the total, we know that the total distance will equal the total average speed times the total time. 2 other things we can conclude. First, that the total distance is equal to x1 plus x2 plus x3, and the total time equals t1 plus t2 plus t3. The only unknowns here are my x3, t3, and my xt, tt. I've got 1, 2, 3, 4 equations and 4 unknowns. So now it's just time to make the substitutions. Again, from here, it doesn't matter where you substitute or what you choose to solve for. You can go one of a couple of different ways. In the end, you should still end up with the same answer. If you start solving and end up with some fractions, you probably took the harder way. Not necessarily wrong, but it's going to get a little bit messier. So I'm going to solve one of the easier ways without all the fractions, and this should hopefully look a little bit cleaner. So let's go on and solve. It doesn't matter, again, what you solve for. I think I will solve for, over here, x3 and t3 in terms of everything else. And then I'm going to substitute those in to end up solving for xt, and that's what we're looking for. So let's go on to the next slide. x3 will equal x total minus x1 minus x2. So x3 equals, and just because this is a lot of variables, I'm going to put the numbers in here. X total minus, we already solved, 1,200 meters minus 990 meters. So x3 equals x total minus 2190 meters. T3 equals T total minus T1 minus T2. So this is T total minus 300 seconds minus 180 seconds. So T3 equals T total minus 480 seconds. So I've got x3 and t3 isolated. And these two expressions are going to be substituted into x3 equals v3 t3. So my x3, which equaled x total minus 2190 meters, equals v3 times t total minus 480 seconds. X total equals, sorry, that's not an equals, this is a minus, 2190 meters equals my v3, which we were given, 3 meters per second times t total minus 480 seconds. I'm going to distribute that out. xt minus 2190 meters equals 3 meters per second total time minus 1440 meters. That meters comes from taking meters per second times seconds, canceling out to meters. And now I'm just going to isolate xt. The reason I'm isolating that is because it makes it a little bit less messy. No fractions. So xt equals 3 meters per second tt plus, so we're adding the 2190 here. This is plus 2190. They end up subtracting 750 meters. I've now got my total distance in terms of my total time. If I substitute this into the equation, Vt Tt equals xt, I'll be able to solve for total time. Solving for total time will then allow me to solve for total distance. So Vt Tt equals 3 meters per second Tt plus 750 meters. I'm going on to the next slide because I ran out of room. My Vt was 3.8 meters per second Tt equals 3 meters per second TT plus 750 meters. My only unknown here is TT, so let's solve. 3.8 minus 3 is 0.8. Total time equals 750 meters. So total time equals 937.5 seconds. And this, I forgot my units. Let me add those units in. This should be meters per second with that. So meters divided by meters per second ends up with units of seconds. I've got my total time. I know that my total distance is equal to my total average speed times the total time. So this equals 3.8 meters per second times 937.5 seconds. Multiplying those together gives me a total distance of 3,562.5 meters. Only 2 sig figs, so this rounds to approximately 3,600 meters for the whole walk. Again, there were multiple ways to solve this. Once you got to your 4 equations and 4 unknowns, it was up to you what you wanted to solve in terms of, I chose to go this way. If you chose to go another way, if you want to try and solve this again, you should still arrive at the exact same answer.